Have you ever wondered how your favorite video streaming service knows exactly what movie you want to watch next? Or how a weather app can predict a storm days in advance? The answer, my friends, is data science. And the people behind this magic are called data scientists. Think of them as modern-day explorers. But instead of sailing oceans or climbing mountains, they navigate vast seas of information. They are part scientist, part detective, and part storyteller. Their job is to take a giant, messy pile of numbers and words, data, and find the amazing secrets hidden inside. It's a job that combines curiosity with some very cool science. So, what makes a data scientist so special? They have a unique mix of skills. Imagine a chef who knows all about ingredients, that's statistics and math, knows how to use all the kitchen gadgets, that's computer programming, and also understands what people love to eat, that's business knowledge. A data scientist is just like that. They use computer languages like Python or R to handle data. They use their knowledge of statistics to understand patterns. And they use their understanding of a specific field, like medicine or finance, to ask the right questions. They are the ultimate problem solvers of the digital age. The goal of a data scientist is to help people and companies make smarter decisions. Instead of just guessing, they use evidence. It's like being a detective at a crime scene. A detective doesn't just guess who the culprit is. They look for clues, fingerprints, footprints, and other pieces of evidence. A data scientist does the same thing, but their clues are data points. They gather all the information, examine it carefully, and then present a conclusion based on what the evidence shows. This helps businesses launch the right products, doctors diagnose diseases earlier, and so much more. It's all about using facts to find the best path forward. Becoming a data scientist is a journey of continuous learning and boundless curiosity. The world of data is always changing, with new tools and techniques popping up all the time. It is a field for people who love to ask why and what if. You don't just find an answer, you go on a quest for knowledge. It's about looking at a spreadsheet full of numbers and seeing a story waiting to be told. So, if you love solving puzzles and want to use science to make a real impact on the world, the role of a data scientist might just be the adventure you're looking for. Consider this. Before any science can happen, a data scientist needs data. This is the first and most important step, collecting the raw materials. Think of it like a chef who needs to gather ingredients before they can cook a meal. A data scientist might get data from all sorts of places. It could come from customer surveys, sales records, website clicks, social media posts, or even sensors on a factory machine. Sometimes the data is neat and organized in a database. Other times, it's messy and scattered all over the internet. The goal is to bring all the necessary information together into one place, creating a big digital pantry to work from. Once the data is collected, the real work begins. Raw data is often messy, incomplete, and full of errors. This is where data cleaning comes in, and it's a huge part of the job. It's like washing and chopping vegetables before you cook them. You have to remove the dirt and the bad parts. A data scientist will look for mistakes, like a person's age being listed as 200 years old. They will handle missing information. What do you do if a customer didn't list their city? They also make sure all the data is in the same format, like making sure all dates are written as year, month, day. This step is critical because bad data leads to bad results. This cleaning process can be time-consuming, but it is absolutely essential. It's like building a house. You need a strong, level foundation before you can put up the walls and the roof. If your foundation is weak or crooked, the whole house could fall down. In data science, clean data is that strong foundation. Data scientists use special tools and write computer scripts to automate a lot of this cleaning. They might write code to find and remove duplicate entries or to fill in missing values with a logical guess, like the average value. It's a meticulous process that requires a lot of patience and attention to detail. Ultimately, the goal of data collection and cleaning is to create a high-quality, trustworthy dataset. This is the bedrock upon which all further analysis will be built. Without this careful preparation, any patterns or insights the data scientist finds later might be completely wrong. They would be making conclusions based on flawed information. So, while it might not be the most glamorous part of the job, gathering and tidying up data is where every successful data science project begins. It ensures that the science that follows is sound, reliable, and truly insightful. It's science in action right from the very start. Now that we have our clean, organized data, it's time for the fun to begin. This is the exploration phase. A data scientist puts on their explorer's hat and dives into the dataset to see what they can find. This is called exploratory data analysis, or EDA. The main goal here is to understand the data's main characteristics. It's like walking into a new forest for the first time. You look around to see what kinds of trees are there, what animals live there, and where the rivers flow. You are not looking for anything specific yet. You are just trying to get a feel for the landscape. To explore this digital wilderness, data scientists use statistics and visualization tools. They might calculate simple things first, like the average, median, and mode of a set of numbers. For example, in a dataset of customer ages, they'd find the average age. They look at the minimum and maximum values to understand the range. They also look for relationships between different pieces of data. For instance, do older customers tend to spend more money? Or do people in certain cities buy a particular product more often? These initial questions help uncover the first clues hidden within the data. Visualizing data is a superpower for any data scientist. A picture is worth 1,000 numbers. Instead of staring at endless rows and columns, they create charts and graphs to make the data easier to understand. They might use a bar chart to compare sales across different regions, a line graph to show how website traffic has changed over time, or a scatter plot to see the relationship between two variables, like advertising spending and sales. These visuals can instantly reveal patterns, trends, and outliers that would be nearly impossible to spot in a simple table. It's about turning data into a story you can see. This exploration phase is all about curiosity and discovery. The data scientist is looking for interesting patterns, strange anomalies, and potential stories that the data might be telling. They are forming hypotheses, educated guesses, that they can test later on. For example, they might notice that sales spike every weekend and form a hypothesis that they should run promotions on Saturdays and Sundays. This exploratory work guides the entire rest of the project. It helps the data scientist decide which questions to investigate further and what kind of predictive models to build next. It's the spark of discovery that lights the way. After exploring the data, the next step is a bit like being an artist or an engineer. It's called feature engineering. A feature is just a fancy word for a piece of information, a variable, that a predictive model can use. Think of it like this. If you want to predict the price of a house, its features might be its size in square feet, the number of bedrooms, and its location. Feature engineering is the creative process of selecting the most important features and even creating new ones from the existing data. It's about giving your model the best possible building blocks to work with. Why is this so important? Well, the quality of your features directly impacts the quality of your results. You could have the most powerful predictive model in the world, but if you feed it irrelevant or poorly constructed features, it won't be able to make good predictions. It would be like trying to build a strong wall with crumbling bricks. A data scientist uses their knowledge of the business and their creativity to craft useful features. For example, from a simple date of purchase data point, they could engineer new features like day of the week, month, or is it a holiday? These new features might be much better at predicting sales. This process is a blend of science and art. The science part involves using statistical techniques to understand which features have the strongest relationship with the outcome you are trying to predict. The art part involves brainstorming and experimenting. A data scientist might combine two features to create a new one, like creating a customer loyalty score by combining the frequency of purchases with the total amount spent. They might also transform existing features to make them more useful, such as converting a text-based category into a numerical value that a model can understand. It's a process of trial and error, seeing what works best. Ultimately, great feature engineering can be the difference between a mediocre model and a highly accurate one. It's where a data scientist's deep understanding of the problem really shines. By carefully selecting and creating the right features, they are essentially highlighting the most important clues for the model to use. They are simplifying the problem and pointing the model in the right direction. This step ensures that the subsequent model building phase has the best possible chance of success, leading to more accurate predictions and more valuable insights for the business. It's about preparing the perfect ingredients for the final recipe. With our beautifully engineered features ready, it's time to build the crystal ball, the predictive model. This is where the magic of machine learning comes into play. A model is, well, a mathematical engine that learns patterns from historical data in order to make predictions about the future. A data scientist's job is to choose the right type of model for the problem they are trying to solve. There are, many different types, each with its own strengths. For example, a classification model might be used to predict if an email is spam or not spam. A regression model might be used to predict a number, like the future price of a stock. Choosing the right model is just the beginning. The data scientist then trains the model. This involves feeding it the historical data we prepared earlier. The model looks at the features and the corresponding outcomes in the training data and learns the relationships between them. For instance, to predict customer churn, when a customer stops using a service, the model would look at thousands of past customer profiles, their usage, their complaints, their plan type, and learn which patterns are associated with customers who left. It's kind of like a student studying for a test by reviewing past exam questions and answers. After training, the model needs to be tested. This is a crucial step to ensure it actually works. The data scientist uses a separate set of data called the testing data that the model has never seen before. They feed the features from the testing data into the model and see how accurate its predictions are compared to the actual outcomes. This helps them understand if the model has truly learned the underlying patterns or if it has just memorized the training data. They use various metrics to measure performance, fine-tuning the model's settings to make it as accurate and reliable as possible. Once the model is trained and tested, it's ready for deployment. This means putting it into a real-world environment where it can start making live predictions. For an e-commerce site, this could mean deploying a recommendation engine that suggests products to customers in real time. For a bank, it could be a fraud detection model that flags suspicious transactions as they happen. The job doesn't end there, though. Data scientists must continue to monitor the model's performance over time to make sure it stays accurate as new data comes in. It's about creating a living, breathing system that provides continuous value. A data scientist could build the most brilliant, accurate model in the world, but if no one understands what it means or how to use it, it's honestly kind of worthless. This is why the final step, communication, is one of the most important skills a data scientist can have. They must be able to translate their complex findings into a clear, simple, and compelling story that everyone can understand, from company executives to marketing teams. It's not just about showing charts and numbers. It's about explaining what those charts and numbers mean for the business. It's about answering the question, so what? To do this effectively, data scientists use a combination of tools and techniques. They create dashboards, which are interactive displays of key metrics and visuals that allow people to explore the data for themselves. They prepare presentations with clear, concise slides that highlight the most important insights. They often use storytelling techniques to make their findings more engaging. For example, instead of saying, "Our model shows a 15% increase in customer engagement with the new feature," they might say, "Our new feature is a hit. Customers who use it are staying on our app longer and buying more. And here's the story of how. The audience is key." A good data scientist knows how to tailor their communication style to the people they are talking to. When presenting to other technical experts, they can go deep into the details of the model and the statistical methods they used. But when presenting to the CEO or the head of marketing, they need to focus on the big picture, the business implications, and the recommended actions. They avoid jargon and technical terms, using analogies and simple language to get their point across. The goal is to empower others with knowledge, not to confuse them with complexity. Ultimately, the value of data science is realized when it drives action. The final report or presentation should always include clear, actionable recommendations. Based on their analysis, the data scientist might suggest that the company should target a new customer segment, change the price of a product, or invest in a new marketing campaign. By effectively communicating their insights and telling a powerful story with data, the data scientist bridges the gap between technical analysis and real-world business strategy. They ensure that their hard work leads to smarter decisions and tangible results. Data science is rarely a solo sport. It's a team game. A data scientist works with a wide variety of people, each bringing their own expertise to the table. This collaboration is essential for a project's success. For instance, they work closely with data engineers, who are the experts at building the systems that collect and store massive amounts of data. The data engineer builds the pipelines that deliver clean, reliable data to the data scientist, making their analysis possible. Think of the data engineer as the one who builds the library, and the data scientist as the one who reads the books inside. They also collaborate with business stakeholders. These are the people from departments like marketing, sales, finance, or product development. These individuals have deep knowledge of the business domain. They understand the customers, the market, and the challenges the company is facing. They help the data scientist understand the problem and ask the right questions. A data scientist might be an expert in data, but the marketing manager is the expert in marketing. By working together, they can ensure that the data science project is focused on solving a real important business problem. Within the technology team, a data scientist also partners with software engineers and machine learning engineers. After a data scientist builds a successful prototype model, it often needs to be integrated into a larger software application. A software engineer helps with this integration, making sure the model works smoothly within the company's website or mobile app. A machine learning engineer specializes in taking models from the research phase to a large-scale production environment, ensuring they are efficient, scalable, and reliable. This teamwork turns a great idea into a working product that millions of people can use. Furthermore, the world of data science is always changing. New tools, algorithms, and techniques are developed all the time. This makes continuous learning a core part of the job. Data scientists must stay curious and constantly update their skills. They read research papers, take online courses, attend conferences, and collaborate with their peers to learn about the latest advancements. This collaborative and learning-focused mindset is what keeps them at the cutting edge. It ensures they can always bring the best, most modern solutions to the problems they are trying to solve. Teamwork and learning go hand in hand. The impact of data science can be seen everywhere, in almost every industry you can think of. It's not just an abstract concept, it's solving real problems every single day. In healthcare, for example, data scientists analyze medical images like X-rays and MRIs to help doctors detect diseases like cancer earlier and more accurately than ever before. They also analyze patient data to predict which patients are at high risk for certain conditions, allowing for preventive care that can save lives. It's like giving doctors a superpower to see into the future of a patient's health. In the world of finance, data science is essential. Banks use machine learning models to detect fraudulent credit card transactions in real time, protecting customers from theft. When you get a text message from your bank asking if you just made a purchase in another country, that's data science at work. Investment firms use complex models to analyze market trends and predict stock prices, helping them make smarter investment decisions. It provides a layer of security and intelligence that is critical in the fast-paced world of money and banking. Retail and e-commerce companies have been transformed by data science. When you shop online, recommendation engines analyze your past purchases and browsing history to suggest products you might like. This is called personalization, and it makes your shopping experience better. Supermarkets use data science to manage their inventory, predicting exactly how much milk or bread they need to order to avoid running out without having too much waste. They analyze customer loyalty card data to understand buying patterns and offer personalized coupons and discounts, making you a happier shopper. The applications are truly endless. In transportation, data science helps logistics companies plan the most efficient delivery routes for their trucks, saving fuel and time. In entertainment, streaming services like Netflix analyze viewing data to decide which new TV shows and movies to produce. They are not just guessing what people want to watch, they know based on the data. Even in farming, data from satellites and sensors in the soil helps farmers know exactly when to water and fertilize their crops, increasing yields and promoting sustainability. Data science is a powerful tool for making things better, smarter, and more efficient for everyone. In a world overflowing with information, data scientists have emerged as some of the most valuable players in any organization. They are the sense makers, the translators who can turn the noise of raw data into clear, meaningful insights. We've seen how they are part detective, part engineer, and part storyteller. They start by gathering and cleaning messy data, transforming it into a pristine resource ready for analysis. This foundational work, though often unseen, is the bedrock of all the discoveries that follow. Without this careful preparation, the entire process would fail. Through their exploration, they uncover hidden patterns and trends, using visualizations to make complex information understandable to everyone. They are like cartographers mapping a new world. Then, with creativity and skill, they engineer features and build powerful machine learning models, our modern crystal balls, that can predict future outcomes with remarkable accuracy. Whether it's forecasting sales, identifying at-risk patients, or recommending the perfect movie, these models are changing how we live and work, making our world more efficient and personalized. But the technical skills are only half the story. The true power of a data scientist is unlocked through their ability to collaborate and communicate. They work with teams across a company, from engineers to executives, ensuring their work is relevant and impactful. They tell compelling stories with data, translating complex findings into actionable recommendations that drive smart business decisions. They don't just find the answer, they inspire the change that needs to happen based on that answer. This makes them a bridge between the world of technology and the world of strategy. So, the next time you get a perfect product recommendation, or your navigation app finds a faster route to avoid traffic, remember the data scientists behind the scenes. They are the superheroes of the digital age, using their powers of curiosity, logic, and science to solve some of the world's most interesting and important problems. They are shaping the future, one dataset at a time, making our world a smarter, better informed place. And that, my friends, is a pretty amazing thing to be. Science rules.